Neanderthals. Homo neanderthalensis, if you want to be formal about it, were a group of archaic humans who lived across Europe and Western and Central Asia for hundreds of thousands of years. They hunted massive animals. They cooked their food. They buried their dead. They made art. Their brains were on average larger than yours. And then, around 40,000 years ago, they vanished. What happened to them is one of the great unsolved mysteries of our species. But before we get to the ending, we need to understand who they actually were. Etymology. What's in a name? First things first. Where does the word even come from? In 1856, workers quarrying limestone in a valley in western Germany unearthed some unusual bones. The valley was called the Neander Valley Neanderthal in German, meaning Neander's Valley. And Neander himself? A 17th century theologian and hymn writer named Joachim Neander, who liked to take long walks there. His grandfather, a musician, had actually changed the family name from plain old Neumann, meaning new man, to the fancier Greco-Roman form Neander, because that was fashionable at the time. Apparently, even in the 1600s, people were rebranding themselves for the aesthetic. So, the most famous prehistoric human in history is named after a rebranded theologian's favorite hiking spot. In 1863, Irish geologist William King formally proposed the name Homo neanderthalensis and recognized them as a species distinct from modern humans. Then, in 1864, he went further and suggested they should be in a completely different genus, comparing their brain case to a chimpanzee's and arguing they were incapable of moral and theistic conceptions. Bold claim, William. Bold claim. Discovery, history. The long road to respect. Here's a twist. The bones found in the Neander Valley in 1856 were not actually the first Neanderthal remains ever discovered. They were just the first ones anyone took seriously. A skull had been pulled from a cave in Belgium as early as 1829. Nobody knew what it was. Another skull turned up in Gibraltar in 1848. The Gibraltar Scientific Society looked at it, shrugged, and concluded it was probably just a modern human, filed and forgotten. Then came 1856 and the Neander Valley, and this time a local schoolteacher named Johann Karl Fuhlrott looked at the bones and thought, "Wait, this is not like us." He passed them to an anthropologist. Word spread. The debate began. Not everyone was convinced. Rudolf Virchow, a very important pathologist who was wrong about this in a spectacular fashion, looked at the bones in 1872 and declared they showed evidence of disease, malformation, and senility. Not an ancient human, he argued, just a sick one. This set the field back by roughly 30 years. One man's confident misdiagnosis and an entire species had to wait in obscurity. By the early 20th century, enough fossils had surfaced across Europe that Neanderthals could no longer be explained away. The most influential specimen was a French Neanderthal archaeologist nicknamed the Old Man, unearthed at La Chapelle-aux-Saints. French paleontologist Marcel Ambouli got hold of it and published a detailed description. Slouching posture, bent knees, ape-like, primitive, a distant offshoot of the human line. Boule's Neanderthal became the definitive image for decades. Postcards, newspaper illustrations, museum dioramas all showed the same hunched, dim-eyed brute. There was one small problem. The old man had severe arthritis. Boule had based his entire reconstruction of a species on a skeleton that could barely walk due to joint disease. It's like studying modern humans exclusively through the remains of someone with a bad back and concluding we all move like that. By 1939, the pendulum had swung far enough that American anthropologist Carlton Kuhn reconstructed the same Neanderthal specimen dressed in a modern business suit and hat, arguing that if you cleaned him up and put him on the subway, nobody would look twice. From cave brute to commuter in 40 years. That's quite a rehabilitation arc. Taxonomy and classification. The identity crisis. Are Neanderthals a separate species, or just a very stocky variety of us? Scientists have been arguing about this for over a century, and they haven't quite finished. The official position is Homo neanderthalensis, a distinct species. But a vocal group of researchers prefers Homo sapiens neanderthalensis, a subspecies of us, essentially saying they were a regional variety of modern human, rather than a separate branch. Think of it less like a different species and more like a different model of the same car. The argument got considerably more interesting in 2010 when the first complete Neanderthal genome was published, and it turned out that Neanderthals and modern humans had interbred more than once, which raises a rather delicate question about what it means to be a separate species when you're quite clearly having children together. Biologically speaking, the ability to interbreed and produce fertile offspring is the classic definition of the same species. But there are also signs of hybrid incompatibility in the data, meaning some of the crossbreeding may have produced offspring that struggle to survive or reproduce, which would push them back towards separate species territory. The uncomfortable answer is that the concept of species is fuzzier than it sounds, and Neanderthals sit right on that fuzzy line, like they were designed specifically to embarrass taxonomists. Evolution and origins. Where they came from. Neanderthals didn't appear overnight. They were the product of hundreds of thousands of years of slow, grinding adaptation. Their characteristic skull features start showing up in the European fossil record at the beginning of the Middle Pleistocene, roughly 800,000 to 400,000 years ago, in a group scientists usually call Homo heidelbergensis. These were the pre-Neanderthals, the rough drafts. They gradually accumulated the classic Neanderthal look over generations as their populations adapted to the cold. Scientists call this process Neanderthalization, which sounds like something that happens to you after 6 months without sunlight and too many carbohydrates, but in this case refers to a suite of specific physical changes driven by natural selection in Ice Age Europe. The cold shaped them. Short limbs, wide chests, stocky frames. These are all features that reduce heat loss in freezing temperatures. The same logic that explains why people from colder climates tend to have stockier builds than people from warmer ones. Modern Inuit groups are actually used as the closest living analogy when researchers try to understand how Neanderthals functioned in their environment. Glacial periods also periodically collapsed Neanderthal populations into small, isolated pockets, like passengers stranded at different airports when all the flights are cancelled. Trapped in those small groups, genetic drift took over, and the distinctively Neanderthal features became even more pronounced. The split between Neanderthals and our own ancestors happened somewhere between 400,000 and 800,000 years ago, depending on which study you believe. Before that split, the common ancestors of both Neanderthals and the Denisovans had already migrated out of Africa and apparently encountered and interbred with an even earlier unnamed human species already living in Eurasia. A group so ancient and obscure that scientists simply call them super archaics, layers within layers, ancestors all the way down. Anatomy. What they actually looked like. Forget the hunch. Neanderthals stood fully upright. Average height for males was around 165 centimeters, about 5'5", and they weighed roughly 75 kilograms. Females were shorter and lighter. By modern standards, they'd be on the shorter side, but not dramatically so. You'd notice them at a party, but not because they were small. You'd notice them because of the face. The Neanderthal skull was distinctive in ways that go beyond just big brow ridge. The brow ridge was indeed prominent and rounded, a heavy shelf of bone above the eyes that jutted forward like a permanent expression of mild disapproval. Behind it, the skull was long and low, flatter than ours. At the back, a rounded bony projection called the occipital bun, sometimes called a chignon by researchers who prefer their anatomy to sound Parisian. The nose was broad. The face projected far forward from the base of the skull, a feature called mid-facial prognathism, which sounds clinical, but basically means their whole face was pushed forward relative to ours, like someone pressed it from behind. The teeth were enormous, the front teeth especially large, heavily worn, with thick roots. The leading theory is that Neanderthals regularly used their front teeth as a third hand, gripping and processing objects with their mouths the way you might hold something between your teeth when your hands are full. Over generations, this put so much stress on the jaw that the whole dental architecture adapted around it. Now, the brain. Neanderthal brains were, on average, larger than modern human brains. Males averaged around 1,640 cubic centimeters. Females around 1,460. Recent European males average about 1,350. This is not a small difference. By raw volume, Neanderthals outbrained us. The catch is organization. Neanderthal brains were shaped differently, proportionally smaller in the regions associated with decision-making, language, memory, and fine motor control. Bigger overall, but configured differently, like a computer with more RAM, but an older processor. You can argue about which matters more. They also had wide, deep chests with longer and straighter ribs, giving them an expansive thoracic cavity and, likely, better lung capacity. Their limbs were short relative to their torsos, classic cold climate adaptation. And there's good evidence that they were effective sprinters, built more like running backs than marathon runners. Skin and hair color ranged across the population, from dark to light, just as it does in any wide-ranging human group. Red hair appears to have been possible, but rare, a genetic quirk that showed up occasionally, like it does today. They were, in short, stocky, strong, large-brained humans with distinctive faces and a bite that could crack things modern humans would use tools for. Not monsters, not apes, just a different kind of person. Population and inbreeding, the numbers problem. Here is where things start to go quietly wrong for the Neanderthals. For their entire existence, they were few. Genetic estimates suggest the effective breeding population, the number of individuals actually contributing to reproduction at any given time, was somewhere between 3,000 and 12,000, spread across all of Europe and Western Asia. To put that in perspective, a mid-sized music festival has more people than the entire Neanderthal species at its peak. At the same time, modern human populations were roughly 10 times larger. Small populations do something brutal to genetics. When there aren't many of you and everyone in your group is distantly related, harmful mutations stop getting filtered out. Natural selection needs variation to work with. It's a numbers game. With only a few thousand individuals across the entire species, mutations that would normally disappear just stayed, got passed down, accumulated. This is called inbreeding depression, and it's exactly as grim as it sounds. There were at least 3 geographically distinct Neanderthal populations, one in Western Europe, one along the Mediterranean coast, one east of the Caucasus. They exchanged genes occasionally, like polite exes who still run into each other at weddings, but not enough to maintain robust genetic diversity across the whole species. The result was a population perpetually hovering near a genetic cliff edge, not falling off, but not stepping back either. Whether this directly caused their extinction is debated, but it certainly didn't help. Behavior and society. How they actually lived. Neanderthals lived in small groups, probably bands of 10 to 15 individuals, family units, effectively. Evidence from a cave in Spain suggests a group of around 13. Adults, adolescents, juveniles, 1 infant. A site in Siberia's Altai Mountains revealed 6 adults and 5 children, including what genetic analysis confirmed was a father, his daughter, and what appear to be cousins. That family may have died of starvation together. These weren't roaming herds. They were families. Bands moved seasonally between caves, returning to the same locations year after year, generation after generation. Some sites show evidence of continuous habitation for over 100 years. They had regular places, they knew the landscape, they went home. Most of the raw materials Neanderthals used came from within 5 kilometers of their base. A small number of artifacts found at certain sites originated up to 300 kilometers away, which means some form of long-distance contact did exist, possibly through chains of neighboring groups trading hand to hand. But their world was, by any modern measure, very small. Lived close, stayed close. Children were weaned around 2.5 years old, about the same as modern hunter-gatherers. Evidence of stunted growth in many Neanderthal children's bones suggests they were put to work almost immediately. By adolescence, they were expected to participate in hunting dangerous game. There was no long, comfortable runway to adulthood. You weaned, you worked, you hunted mammoths. Now, technology. For a long time, the Mousterian stone tools Neanderthals made were dismissed as crude and unsophisticated. Compared to the blade technologies that came later with Cro-Magnons, they look simpler. But simple is not the same as stupid. Mousterian tools were carefully made, deliberately shaped, and served their purpose effectively for over 150,000 years. They also built hearths, maintained fire, and possibly created it from scratch, though this is still debated. They crafted simple clothing, not tailored suits, but functional wraps and blankets for surviving Ice Age winters. They stored food. They cooked it roasting, boiling, smoking. They used medicinal plants. They treated injuries, including severe ones. A number of Neanderthal skeletons show healed fractures from major traumas, injuries so serious that surviving them required weeks or months of care from other group members. They kept each other alive. That is not nothing. And then there's the art question. Ornaments made from eagle claws and feathers. Collections of crystals and unusual fossils gathered and kept for no apparent practical reason. Engravings in cave walls. Red ochre pigment. In some caves in Spain, abstract markings on walls have been dated to before modern humans arrived in the area at all, which would make them definitively Neanderthal. None of this is conclusive. Archaeologists argue endlessly about whether each piece of evidence truly represents symbolic thought or has some mundane explanation. But the cumulative picture is hard to dismiss entirely. Something was happening there. Something more than survival. Neanderthals also buried their dead, deliberately, in some cases with grave goods, animal bones, flower pollen, ochre. Whether this reflects grief, ritual, belief in an afterlife, or simply a practical desire not to have a body decomposing in the cave is unknown. But they put their dead in the ground, and that is a very human thing to do. Diet. What was on the menu? Neanderthals ate whatever was there, which in Ice Age Europe was often enormous. Their primary prey was large hoofed mammals, red deer, reindeer, bison, horse. When those were around, Neanderthals ate them. When something bigger came along, woolly mammoths, woolly rhinoceroses, cave bears, they apparently ate those too. Coastal populations added shellfish, fish, and marine mammals. Inland populations supplemented their diet with plants, mushrooms, and small game. They were apex predators, at the top of the food chain. Except, and this is a genuinely stressful detail, they shared that top with cave lions, cave hyenas, and other large carnivores who also needed the same caves for shelter, the same prey for food. Neanderthals weren't just hunting things. They were also, regularly, in competition with things that were trying to eat them. Their bones tell this story clearly. Neanderthal skeletons show an unusually high frequency of traumatic injuries, broken bones, healed puncture wounds, crushed joints. The pattern is similar to what you'd see in modern rodeo riders. Close contact trauma from very large animals. They apparently hunted by getting extremely close. By choice, repeatedly. Despite the occupational hazards, they were sophisticated enough to cook. Roasting, boiling, smoking, all documented in the archaeological record. They were not simply eating things raw off the bone like the cartoons suggest. They were processing, preparing, and preserving food like any reasonably organized human group would. Genetics and interbreeding. The awkward family reunion. In 2010, when scientists published the first complete Neanderthal genome, they discovered something that rewrote the story entirely. Modern humans of non-African ancestry carry Neanderthal DNA. Not a trace, not a statistical ghost. Actual measurable Neanderthal genetic materials, somewhere between 1 and 4% of the genome in most people with European or Asian ancestry. The Neanderthal genome didn't disappear when the species went extinct. It merged. It got absorbed. It is, right now, sitting in the cells of a significant portion of the human population, doing things. The main interbreeding event appears to have happened roughly 50,000 to 65,000 years ago in the Near East, when modern humans first pushed out of Africa and walked into territory Neanderthals had occupied for hundreds of thousands of years. They met, and apparently got along, at least briefly, in the most consequential way. This wasn't a one-time event. There were multiple episodes of interbreeding across different times and places. In total, around 20% of the complete Neanderthal genome survives somewhere in the modern human population, scattered across billions of people, a few percent at a time, like a species dispersed rather than deleted. Most of those Neanderthal gene variants are in non-coding regions of the genome sections that don't directly make proteins, and many have been slowly filtered out by natural selection over the millennia. Neanderthal genes that caused problems in the new genetic context got weeded out, but some stayed, and some were actively useful. Neanderthal-derived variants have been linked to immune system function specifically, variants that helped early modern humans cope with Eurasian pathogens they hadn't encountered in Africa. Some are involved in blood clotting, some affect skin and hair. Some appear to influence susceptibility to certain diseases today in ways researchers are still mapping. Neanderthals also interbred with Denisovans. Scientists have found the actual skeletal remains of a first-generation hybrid, a young female with a Neanderthal mother and a Denisovan father, found in a Siberian cave. 2 species, 1 child, 90,000 years ago. The ancient world was messier and more interconnected than the textbooks used to suggest. The genetic picture that's emerged is not one of 2 separate lineages running in parallel, and then one destroying the other. It's a braided river merging, splitting, merging again, with genes flowing between groups across vast spans of time and space. Extinction, the end of the line. Around 40,000 years ago, Neanderthals disappeared. Not instantly, not dramatically, gradually, and then completely. The transition is visible in the archaeological record as a near-total replacement of Neanderthal stone tool traditions with modern human ones, sweeping across Europe between 41,000 and 39,000 years ago. Northwestern European Neanderthals were gone by around 40,600 years ago. Iberian populations possibly sheltered south of the Ebro River, which may have served as a natural barrier to modern human expansion, perhaps lasted until 35,000 years ago. A handful of contested sites suggest even later survival in southern Spain and the Ural Mountains. But the debate around those dates is fierce, and the mainstream view is that by 38,000 years ago, they were gone from everywhere. Why? Nobody knows for certain, which is both intellectually honest and deeply unsatisfying. The leading hypotheses, and there are several, probably all contributed. Competitive replacement. Modern humans arrived with larger populations, wider trade networks, and more flexible technologies. When 2 groups compete for the same caves, the same herds, the same river valleys, the bigger and better connected group tends to win. Not necessarily through violence, though violence was probably also a factor, but through simple demographic pressure. More people means more hunters, more foragers, more children surviving to adulthood. Neanderthals, already stretched thin across a vast territory with a tiny population, had no buffer. Disease. Modern humans coming out of Africa had spent tens of thousands of years evolving resistance to a dense, diverse pathogen environment. Neanderthals had not. When the 2 groups met, modern humans may have carried infections that spread through Neanderthal communities like a disease through a population with no immunity and no numbers to absorb the losses. The parallel to what happened when European diseases reached the Americas in the 16th century is not a comfortable one, but researchers have explicitly made it. Absorption. Some researchers argue the Neanderthals didn't go extinct so much as they dissolved. Enough interbreeding, sustained over enough generations, and a small population can effectively be absorbed into a larger one, its genes surviving, its identity disappearing. This is not extinction in the dramatic sense. It's more like being outvoted, slowly, over thousands of years. Climate change. The period around 40,000 years ago was marked by rapid and extreme climate fluctuations, temperature swings that repeatedly destabilized ecosystems across Europe. For a species already operating on thin genetic and demographic margins, the kind of environmental disruption could have been the last straw. Mutational meltdown. The accumulated genetic burden of inbreeding and small population size may have quietly degraded Neanderthal reproductive success over generations. More birth defects, more infant mortality, lower fertility, until the numbers simply couldn't hold. The most honest answer is probably all of the above, in different proportions, in different places, at different times. There was no single moment, no final Neanderthal, just a slow, undramatic fading, a species that had survived ice ages, predators, and hundreds of thousands of years of brutal conditions, finally running out of road. Legacy. What they left behind. Neanderthals are extinct. That much is certain. Everything else is more complicated. 1 to 4% of your genome traces back to individuals who lived in Ice Age Europe and Western Asia and interbred with your ancestors somewhere in the ancient Near East. That DNA is not inert. It is doing things influencing your immune system, your blood, possibly your susceptibility to certain diseases. You are, in a very literal biological sense, partly Neanderthal. The word itself has become an insult, which is ironic given that the actual Neanderthals were large-brained, fire-using, art-making, grief-feeling humans who survived conditions that would be considered uninhabitable today. Calling someone a Neanderthal to suggest they're stupid or primitive is a bit like calling someone a caveman to insult them, and then discovering that the caveman in question had a larger brain than you, cooked their food, made jewelry, and buried their dead with flowers. The popular image has shifted, slowly, reluctantly, but it has shifted. Modern reconstructions of Neanderthals based on actual anatomy, pigmentation genetics, and everything else science has accumulated show something that looks recognizably human. A different kind of human, yes, but human. They lived for hundreds of thousands of years. They survived multiple ice ages. They raised children, cared for their injured, returned to the same places season after season, as if those places were home because they were. They looked up at the same stars and, for all we know, wondered about them too. We don't know exactly why they vanished. We don't know what they sounded like, what they called themselves, whether they had anything resembling stories or songs or the kind of shared mythology that humans use to make sense of the world. What we know is that they were here for an almost incomprehensibly long time, and then they weren't, and that some part of them, in many of us, still is.